Okay, so this is to help understand quadrant 2 in the trigonometric unit circle, and it assumes that you already understand quadrant 1. So if you don't, then you should, there is a video available to take a look at that quadrant first. Okay, so we're looking at angles in quadrant 2, so let's start with an example. Let's start with an angle that is 2 pi over 3 radians. So if I were to draw that, here is the positive x-axis right here. So that's our start side, and then our terminal side, the terminal side of the angle is going to end somewhere in here if it's 2 pi over 3. Because remember, this is pi over 2 radians. From here to here is pi over 2 radians. And then from here to here would be pi radians. So 2 pi over 3 would be somewhere around here. All right, so in order to find the sine or cosine or tangent of this angle, alpha, we need to have a right triangle that goes to here, okay? And we can't draw a right triangle that has more than 90 degrees, and pi over 2 is 90 degrees. So that's where the unit circle comes in handy, and because we're going to need a unit circle rather than a right triangle to find the sine value and the cosine value and the tangent value at 2 pi over 3 radians. However, we are going to find it useful to draw a reference angle and have a right triangle there. So the reference angle of any angle is, if the angle is greater than 90 degrees, the reference angle is the angle that this terminal side makes with the closest x-axis, the positive or negative. So it's either going to be positive with the positive x-axis or the negative x-axis. And because the negative x-axis is closer or makes a smaller angle, we're going to use the negative x-axis in this situation. So the reference angle of an angle is always going to be an angle from the terminal side of the angle to the closest x-axis. And it's always less than pi over 2 degrees, or excuse me, radians. So always less than pi over 2 radians. Okay. All right, because it's always less than pi over 2 radians, you can draw a right triangle with it. So I'm going to draw a right triangle right here. And that's the reference angle right there, theta. Well, how many radians is theta? To find that, I know that going all the way around would have been pi, but I only went around this much for the alpha. So I'm going to do pi minus alpha to get my reference angle. So that's going to be pi minus, in this case, 2 pi over 3 radians. To subtract that, I'm going to need to get a common denominator. So we're going to change this to 3 pi over 3 minus 2 pi over 3. Let's just put this in parentheses there. 3 pi over 3 minus 2 pi over 3. Subtract that, you get 1 pi over 3. So the reference angle is 1 pi over 3. And if I make a triangle outside, just as so I can remember how my triangle works, the opposite of pi over 6 is 1. The hypotenuse is 2. Pi over 3 is root 3. I can use this to find now my sine, my cosine, and my tangent of pi over 3, which turns out to have the exact same sine, cosine, and tangent values of 2 pi over 3, as long as the signs are for the second quadrant instead of the first quadrant, okay? So sine of 2 pi over 3 is equal to the sine of pi over 3. So that's going to be opposite over hypotenuse, so root 3 over 2. Because the sine value in the second quadrant is positive, because the sine value is the y value. So this is the sine value. So because the y value is positive in the second quadrant, my sine value is also positive. So now we're going to do the cosine value. The cosine of 2 pi over 3, try and find that. If you took a look at this angle and found the cosine and used adjacent over hypotenuse, so adjacent is 1, then you would be correct to get 1/2. However, we need to fix one thing, and think about what that is. remember that the cosine value over here is the same as the x value. So cosine is going to be a negative value because x is negative in the second quadrant. So this is going to be negative 1/2 instead of positive 1/2. And last but not least is tan 2 pi over 3. Tangent is going to be opposite over adjacent, which is going to be root 3 over 1 or root 3. And remember that tangent, you can either remember that tangent is sine over cosine. So if cosine is negative, then my tangent is going to be negative. Or you can remember that tan is, in this case, is opposite over adjacent. Opposite is a positive y, and adjacent is a negative. So that means that positive over negative is going to give me a negative answer for tangent in the second quadrant. So that is one example in the second quadrant right here. The values of sine, cosine, and tangent of 2 pi over 3. Let's do another example. And the next example we're going to use for alpha is going to be 5 pi over 6. So you can go ahead and see if you can figure out all the trig function values of 5 pi over 6. All right, so again, the next angle that we're going to deal with here is going to be 5 pi over 6 radians. So if I draw the angle that is 5 pi over 6 radians, the start side is going to be on this side. The terminal side is going to be almost all the way to pi radians. So it's going to go all the way around, just shy of pi radians. So what would the reference angle be for that? So I'm going to draw that. You should have a picture of the reference angle right here. And it's going to the unit circle. So again, it's going to go out there. My y value is positive. My cosine, my x value is negative, still in the second quadrant. Keep that in mind. My reference angle is going to be pi minus 5 pi over 6. So again, that's because this little bit that's left is going to go all the way to pi, and then you're going to subtract alpha to get the leftover bit, which is theta, or the reference angle. So I'm going to subtract that. I need to get a common denominator, so I change the pi to 6 pi over 6. 6 pi over 6 minus 5 pi over 6 is 1 pi over 6. So my reference angle is pi over 6 radians. Okay. So that means that 5 pi over 6 radians has all the same trig values as pi over 6 radians, except for possibly the positive negative sign. So I'm going to draw a triangle. Let's draw a yellow triangle with pi over 6 radians as my angle here. That's the same as 30 degrees, so opposite is 1. And I'm going to use that to find my trig values here. So sine of 5 pi over 6 equals the same thing as sine of pi over 6, which is 1 opposite over hypotenuse, or 1/2. Cosine of 5 pi over 6 is equal to root 3 over 2, or negative root 3 over 2, because cosine is the same as the x value on my unit circle. So it's going to be a negative value. And then last but not least is tangent of 5 pi over 6, which is opposite over adjacent, or negative 1 over root 3. For calculus, you can leave it as negative 1 over root 3. Rationalizing the denominator is not as important because sometimes it's easier to deal with in the non-rationalized form. But if you want to rationalize it, it's also fine. So either one is okay. Now, what does this mean for the unit circle? For the unit circle, remember that the hypotenuse is always 1. So the hypotenuse is the radius of the circle, and the radius, it's called the unit circle because the radius is 1 unit. It's a unit. So, and the hypotenuse is always the same as the radius, which is from the center of the circle to the outer part. So that means the hypotenuse is always 1, which means that opposite over hypotenuse, for example, if sine of theta equals opposite over hypotenuse, remember that this means that since the hypotenuse is 1, the sine is just equal to the opposite side. So this opposite side, which is the y value, is equal to the sine value. So this is going to, in this case, be sine of 5 pi over 6, which was 1/2. And the bottom side, likewise, because cosine is equal to adjacent over hypotenuse, but the hypotenuse is 1, so the cosine is just equal to the adjacent side, or the adjacent side of the triangle. The x value here is going to be equal to cosine of 5 pi over 6. And if I were to write the coordinate of this point right here, what would that coordinate be? And you should say cosine of 5 pi over 6, comma, sine 5 pi over 6. And because we actually got a value here, we happen to know that that's going to be negative 1 over root 3, comma, 1/2. That is the coordinate of this coordinate right here at the end of that hypotenuse. Okay. So we're going to do another angle, and this time we're going to do 3 pi over 4. So see if you can find the sine, cosine, and tangent of 3 pi over 4. As we said, we are going to take a look at the angle 3 pi over 4 radians. Let's switch back to blue. Okay, so that's going to have a start side. The angle's going to have a start side right here on the positive x-axis, which is where the angle always starts in when you graph it. And then 3 pi over 4 is going to be right about up to here, halfway into the second quadrant. So this is 3 pi over 4 radians. And so see if you can figure out the reference angle, which always goes from the terminal side to the closest x-axis, or the x-axis that makes the smallest angle, the positive or the negative side. So this is the negative side, as has been every angle so far in the second quadrant, and will be every angle in the second quadrant. So my reference angle for this is how many radians? Well, to figure that out, remember that this reference angle is going to be less than pi radians. So it's going to be pi radians minus whatever alpha was. So I take my pi radians and I subtract 3 pi over 4, get a common denominator, get 1 pi over 4 as my reference angle. In order to find all the trig values then of this angle theta, remember that the trig values are going to be such that the coordinate of this point over here is going to be negative x, or whatever the cosine of the angle is. Let's do this in blue because it's going to be the cosine of the 3 pi over 4, comma, sine of 3 pi over 4. And the cosine of 3 pi over 4 is going to end up being negative because the x value is negative. And the sine value is going to end up being what? And if you said positive, you have the right pattern there. All right, so let's go ahead and draw that triangle and figure out those actual numeric values. So my reference angle was pi over 4. I'm going to draw a pi over 4, or 45, 45, 90 triangle. Opposite side is 1, and the hypotenuse is root 2. So the sine of 3 pi over 4 radians is equal to the same thing as the sine of pi over 4. So that's going to be opposite over hypotenuse. And sine is positive in the second quadrant. Cosine of 3 pi over 4 is equal to adjacent over hypotenuse, which is also 1 over root 2. But cosine is negative in the second quadrant. Tangent of 3 pi over 4 is opposite over adjacent, which is going to be 1 over 1, which equals 1. But it's going to be negative because we're in the second quadrant. Okay, and if you divide sine divided by cosine, where sine is positive and cosine is negative, you will get a negative answer for tangent. So what does that mean about the coordinate of this point here at alpha degrees on the unit circle? It means that the x value here is negative 1 over root 2, and the y value is positive 1 over root 2. Okay. All right, let's then do what happens if alpha is pi radians itself. So consider that while the next part is being set up. So we want to take a look at what happens when alpha is pi radians. So remember that if as alpha gets closer to pi radians, think about what happens. When we were dealing with, let's draw that a little more accurately. When we were dealing with 2 pi over 3 radians, the reference angle looks like this. And the sine value, which is the y value, was very high, and the cosine value was very little. So let's even focus on the sine value. The sine value was quite large. Then when we flipped over to pi over 4 radians, that was more like this. And when we were dealing with that angle of pi over 4, our reference triangle looked like this, and our sine value, which is the same thing as the y value of that coordinate point, was a little bit smaller. And then when we dealt with 5 pi over 6, we were actually all the way down here. The reference angle slash triangle looked like this, and the sine value was then much smaller. So what's happening is the closer my angle gets to being pi radians, what happens to my sine value? So basically the triangle collapses on itself so that the sine value is 0. Okay, so for pi radians, the reference angle, if you want to say that, is 0 radians, but there is no real triangle there because it collapses on itself. So you have to kind of just, and at this point, remember that this coordinate point, the x value is the cosine value. Let me do this in blue again. Cosine of pi, and the y value is the sine of pi. And you have to remember equally, if I were to look at this as an xy coordinate, well, the x coordinate of that is -1 and the y coordinate of that is 0. So the sine of pi is going to be 0 radians because the y value at that point is 0. Excuse me, not 0 radians, just 0. The cosine of pi radians is going to be -1 because the x value at that coordinate is -1. And the tangent of pi radians is going to be opposite over y over x, or opposite over adjacent, which is 0 over -1, which equals 0. Notice in this case tangent is not negative, but that's because it's not technically in the second quadrant, it's just adjacent to it's bordering the second quadrant. Another reason why the sine of pi equals 0 is because the angle collapsed on itself, the triangle collapsed in itself, and so the height became 0 because the triangle hypotenuse went flat against the bottom side. And the reason why the cosine equals 1 or -1 is because the bottom side was getting longer and longer. So it was at first this long, then this long, then this long, all the way across. And so when we get down here, it goes all the way across from the center of the circle all the way out. And so it ends up being -1. And that is the second quadrant.